the paper with all the questions on, the homework?
Yeah. We're gonna do it together in class.
Oh, it says
That's why it says
assignment.
2-4, because that's 2 dash points.
What are you talking about?
At the top it says 2-4 proofs.
It does?
Yeah. You use
Oh, no.
18.
Yeah, that's because I'm using an old worksheet there.
Did you really put your Yeah, how long did it take you to?
That came that way.
Yeah, I feel like being a teacher your first year it would be really, really difficult. The next couple years it wouldn't be that bad.
That was really funny, and nobody laughed at it.
Algebraic proofs. What we're gonna start dealing with, these proofs, you're gonna love them.
Okay.
Alright?
Yeah.
All you gotta do is try. I'm not asking you to be great at these, but you got to try. If you do nothing, you get nothing. And I guarantee there'll probably be about half of you in here that's what's gonna happen when we take a test over this stuff. You'll just skip over them. And when we take the test over this, the proofs are gonna be about 50% of the test. And when you don't do 50%, then what's the highest possible grade you can get?
50%.
50%, which is an F.
Yeah.
Now that's 50% if
You're perfect.
perfect on everything else. I wouldn't count on that. Alright?
Alright.
So, on this first one, this is just, we're just gonna do this, together. Write the converse, inverse, contrapositive. Through any 2 points, there's exactly one line. We're gonna start talking more and more about postulates, theorems, different mathematical rules. This is one of those mathematical rules that's a postulate that we dealt with at the start of the year. First thing, let's write this as an if and then statement. I can quit working. How would you write this as a conditional statement, an if and then statement?
If it goes through 2 points, it is one line.
So let's make it so it makes what has to be in the beginning here.
If only. Wait,
If,
no.
if there's any
What-
2 points.
What's our subject?
But line.
A line? Alright, so
It's a graph.
if you have a line, or we're turning it around. What's really the subject?
The points.
So
If you
if
have one line, there's
you're turning it around. If you have what?
Oh.
2 points.
2 points. What's the second half gonna say?
Then there is exactly one line.
Then there is exactly one line. This part's called the what again?
Hypothesis.
Hypothesis.
This part's called the conclusion. We want to write the converse. Instead of me writing these up here, we'll just say them, all right? Converse, inverse, contrapositive. What's the converse do to a statement?
There is exactly one line if you have 2 points.
All right. If there is exactly one line, then you have
2 points.
2 points. Does everybody agree with that?
That's not true, but. Do we have to write these on paper?
I don't, it's up to you. Yeah, I probably would. I mean, you need to know them. But the inverse. What's the inverse do?
Puts not.
Does it switch them?
No, it just puts not.
Leaves them in the same order, but negates both parts. Puts sort of not with both parts. So what? What are you gonna say?
If you have 2 points, then there is not exactly.
Say it again.
If you have 2 points, then there is not exactly.
Forgot something in the first part.
If you do not have 2 points.
Oh.
If you do not have 2 points, then what?
There is not one line.
Then there is not one line, exactly one line. If you do not have 2 points, then there is not exactly one line.
Oh, that's funny.
What's the contrapositive say? What's it do?
Does both.
So it switches them and it negates them. So what would the contrapositive say here?
If you
not have exactly one line,
No, the
then
contrapositive.
there is not exactly 2
Okay,
points.
so
Alright.
No,
it
it's
switches.
So let's write these down, cause it looks like a lot of you aren't doing it. Let's go back to the original, the converse. What's the converse gonna say?
If there's.
If there is
exactly one line.
If there,
Is exactly
if
one line.
there is exactly one line, then you have what? 2 points. Converse. Inverse, what's the inverse do again? Negates them. Go back to the original. Remember, this is the original up here. So what's the original, or what's the inverse of the original gonna say?
If you do not have 2 points, then there is not exactly one line.
Do not have 2 points. And then, what'd you say?
Then there is not exactly one line.
Then there is not exactly one line. What's the contrapositive do?
Flips it and negates it.
So what's it gonna say?
if there is not
There
exactly
is
one,
not
There's
exactly
not exactly
one
one
line.
line,
then you have, and then you
then don't.
yeah, then you don't have 2 points.
If there is not exactly that one line, then what? Then you don't have 2 points. Now, we didn't tell whether each one is true or false or not. Was the original statement true?
Yeah.
So the original statement, that was, like I said, that was a postulate that we had back at the beginning of the year. Got 2 points, any 2 points anywhere in the world, we know that there's what?
One line.
A line that goes to it, exactly one line that goes to it. How about the converse?
No.
If there is exactly one line, so we have exactly one line somewhere. Just imagine you have a line, then you have 2 points.
I mean, yeah,
It has to be
actually,
a straight
because
line.
you have to have 2 points to make a line.
So is there 2 points?
Yeah.
Yeah. Now, see, again, you guys are adding things in. Did it say that we have
Exactly.
exactly 2 points? No, it just said we have 2 points. Do we know we have 2 points? Yeah, we could have 3, 4, 5, because it takes a whole bunch of points to make a line, right? But this is still a true statement. If you do not have 2 points, so you don't have 2 points, then there is not exactly one line. If you don't have 2 points, how many points could you have?
3.
3,
4.
4,
They could all be collinear, so
they could all be collinear.
5,
that's false.
5,
6.
so that one sounds like it's false, because they could be all collinear, right? Now, do we know that they're collinear?
No. But they could be.
They could be, we're not sure, so we can't really say on this one. And the last one, if there is not exactly one line, then you don't have 2 points. If there is not exactly one line,
You don't have one line.
if you don't have one line. Well, if we don't have exactly one line, we could have what?
2.
We could have 2 lines,
Then you have to have 3 points.
or 4 or 5, so what's this one?
True.
It's true. Ends up being true. So we're gonna solve each of these together, get you back into the algebra stuff real quickly.
We solved this first one. What do you do?
Just add 6.
Add 6. Add 6 to both sides. Write that down on your paper.
PIMDAS.
What do we end up with here?
T equals 4. 2.
T equals what?
2.
What did you do to solve that one?
Added 6.
You added 6 to both sides, right?
Yeah.
Alright, added 6 to both sides. That was a rule that you learned last year. How about this next one? Divide both sides by 3. What do you end up with?
7.
What'd you do there?
Divide both sides by 3.
Divided both sides by 3. Next one. What do you do on this one?
Subtract by 9.
Subtract both sides. 9 on both sides. What's that give us?
4. 1x.
And the last one, how do we solve the last one?
Multiply by 7.
Don't let this confuse you just because it looks like a fraction. It's just like any other one, right? You just do the opposite. Here we're multiplying both sides by 7.
X equals 35.
X equals 35.
Good job, Brent. You got it 7 times.
Fill in what you need to fill in on this.
Okay. Josie's getting the odds right.
For Keith?
I said Josie's getting the odds right.
She likes bigger boys.
Gentlemen, do me a favor and scoot your desk back a little bit. I can get close to the wall as you can get. We don't have to bother with it. I'm sure there's gonna be carrying something, otherwise they wouldn't.
I have muscle right Sorry. What did you say?
Ethan, are you still with us? I'm gonna drive you nuts today, man.
Me? Yeah, dude, I love sucking in my ribs.
Do you play fantasy football?
Hey,
Bertzel has best team.
what does that monitor say? If Ebersole has like B.
If A equals B,
I have the most points
then
right now.
A over C equals B over C.
Thank you.
I have the most points by week, and I'm winning my team to make sure.
How many people do you have? My team's probably stat bad. My team's really good for it, because I'm in a 13 team.
I have 2 at Q.
Hey, I gotta steal it. Gino Smith at quarterback.
Bro, stop.
On this, algebraic properties of equality. This is all stuff you should have learned in algebra. The stuff that we're doing today is to try to make some of these 2-column proofs a little easier on you.
What just happened?
My screen comes back. I don't know, it disappears every now and then. Elizabeth, will you do me a favor? Go back in my office area.
This is also
Shake the,
50?
the mouse.
Shake that out on the floor.
See if that does it.
Smack that.
I fall like 12. T is so mad.
Yeah, it looks like it shuts off on us for some reason. It'll take a second to pop back
That's what I
up.
was thinking. But my right receiver is at 16.
16.
Riley, can you hear that? Does it sound like it's running?
Sounds
Hey,
like I'm
Keith.
complaining about it.
Your pants are falling down.
Fix your pants.
That's racist.
I can
Keith,
pull it up
Keith,
for
wear a
you.
belt.
That's racist.
Ow, he needs to wear a belt.
I don't know.
Algebraic properties of equality. As we go through and we do these two-column proofs, you can look over on that next page and you see what the two-column proofs are going to look like. You've got to make a statement and give a reason for how you know you can do that every single time. Right? So unlike last year in algebra, you just did what we just did on those 4 problems and you just did the math, right? Now you're going to have to do the math, give a reason. And these are the reasons that we just used on that other one. And you learned these reasons last year, but once you learned them, then you sort of went away from them and you just solved the equations without thinking about it. All right? Now you're going to have to use them. Notice every single one of these. Underline this. When you're doing this, if you do something to both sides, if you do something to both sides of an equal sign, you have to have that of equality on the end. Does that make sense? Branson, does that make sense?
Yes.
If you do something to both sides of the equal sign, if you do the same thing to both sides, you got to have that of equality. So if you just wrote addition property, it'd be wrong. It's got to have that of equality on the end. As we go through and do this, we're going to use abbreviations. You might want to write these abbreviations down in there. As I do this, I'm not going to write this all out. I don't expect you to write it all out. But you have to have so much of it so that I can tell what it is, otherwise it gets marked wrong. So on this first one, if I was going to abbreviate this so that I have less to write, I would probably write this. Add, prop, of, and then I'd use an equal sign. So if you write that down, then that's acceptable. This one, put an asterisk beside subtraction. And a whole bunch of you are going to mess this one up. And I'm guessing my friend back here that's not paying attention right now will be one of them.
Talking to me.
Are you his
Are you
friend?
not paying attention? I didn't. Josie, did you say me?
No,
Because
Yeah,
you
she
were what?
paying attention.
Paying attention. So those people who jumped up and said me probably weren't doing what? Paying
Well, you
attention.
said my friend back there.
Yeah, I thought we were friends.
You have more than one friend.
Like,
On this one, you cannot abbreviate subtraction. You can write this, I won't mind it if you do this, but it has to be at least that much. Subtract. Anybody have a guess why? Because there's substitution property, very good. So subtract property of equality. If you abbreviate it, just SUB, I'm not going to know which one it is, and I'm not going to come and ask you, I'm just going to mark it wrong.
Good job, Mikael.
Next one, multiplication property. You can abbreviate that. Mult, prop, of, equality. And the last one, you can abbreviate it, division, div, prop, of, equality. I don't mind using stuff. Now, I'm starting to see it already, and even though I've said in every class not to do this, I guarantee I'll have somebody do this. APO equal sign. I'm not even gonna look at it, I'm just gonna mark it wrong. If that's ridiculous. You're not talking to one of your friends on the phone and writing those stupid little things, whatever they are, that I don't know.
Acronyms. Branson, what did you say?
I didn't hear what you said.
They're too close to each
Huh?
other.
I said I didn't hear what you said.
What Branson said?
Yeah.
He said, do we have to write it completely out?
Branson did.
He asked another Branson question. All that stuff that we just went over, he asked another Branson question where we just went over it, how to write it out, how to abbreviate it, and he asked, do we have to write it all out?
My fault.
Now let's go back to the paying attention thing. Do you think he was paying attention?
Who, me?
Absolutely not.
Show your John Deere and beers with yourself.
Huh? So, you can abbreviate things, but don't abbreviate them so that just you can understand. If it's not something I can understand, I'm marking it wrong. And then Luke's going to say, well, how come you couldn't understand it? No. Make it so anybody who looks at it can understand it. Otherwise, it gets marked wrong. Two other properties that you learned last year. Probably even before that, but substitution property. What is substitution property?
Substituting.
You substitute something in. So you take one thing out, substitute something else in its place. Now in math, when you do that, you take something out and substitute something in its place. They gotta be equal to each other. So you can't just take out one thing and stick something else in its place just because you want to. They got to be equal. Right, Ethan O? Cameron, you might have to move. I think I'm gonna have to sit right next to Ethan here pretty soon.
That would be funny.
Help him stay with me.
Sit next to
Then I may
Branson.
have to, I'm gonna have to move Luke right, or not. I'm gonna have to move Branson right up here next to me somewhere so that he can stay focused.
Preferably
Notice, it just says substitution property. It doesn't say substitution property of what?
Equality.
Equality. Because you're not doing something to both sides of the equal sign. You're just taking out one thing, sticking something in its place. Substitution property, you gotta write out the word substitution. You can abbreviate property, that's fine, but this has to be written out. If you don't write it out, then I won't know whether it's substitution or subtraction. Distributed property, could you abbreviate that?
Yes.
How much you abbreviate it to make sure Ebersole understands it? Alright, so tell me what? D-I-S-T-R-I? Could we maybe just go that far, D-I-S-T-R? Yeah, I'd probably, you could go that far, you could go that far. As long as I know what it is, that's all right. If you just abbreviate it, D property, then I'm not gonna know what that is, I don't have any idea. You might wanna draw this in, distributed property, probably learn to draw in the arrows. Distributed property, you just take the number outside and multiply it times everything inside the parentheses. Looking back at substitution property, why might you want to change this equation from this into this?
So that you can add like terms and stuff.
Right, and it's something we can solve then, right? Because it's just got A's in it, not A's and B's. Three properties. I know Mrs. Barnes, Mr. Harrison go over these properties because they've both taught geometry before, so they try to help me out. These are three properties that you probably didn't deal with a whole lot in algebra, but I know that she went over them or he went over them, but we will deal with them a lot in geometry. you get all this, Ethan O? Don't lie to me. Blank, I can see it from here. I'm not even that blind. I thought you were getting to that age where you had some common sense, didn't ask a question that I just answered 2 seconds before.
What was your binder check last quarter? Was it good? Binder check. These things?
We didn't know some racist footy today.
You didn't write this down, it won't be this quarter. You something to write with? He's mad at me now because I'm not letting him sleep.
I feel like I got a slug in my face. It's so bad. It's like pressure.
That's nasty.
A slug.
It's like, ah.
Reflexive property.
I woke up with a bloody.
Very, 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 very important in geometry, reflexive property. All reflexive property says is anything equals itself. Anything equals itself. I know that sounds ridiculous.
Like, of course, obviously, it does.
Right. Reflexive property, anything equals itself. We use it a lot in geometry. One of the things that we're going to do later on in the year as we go. How many triangles do I have in that picture?
2,
3.
3.
All right, there's 3 triangles. What looks to be true about these 2 triangles?
They equal.
They look like they're equal to each other. And what we're going to be able to do is prove that they're equal or congruent to each other.
By measuring.
Now, and we're not going to measure them, we're going to use rules. All right? One of the rules that we're going to use is reflexive property. If I split off those 2 triangles and I'm looking at them, what do I know about this segment and this triangle and this segment and this triangle?
They're the same.
That it's the exact same segment, isn't it? And that's where we're going to use this. We're going to say we know that this segment is equal to this segment because anything equals itself. If I have some triangles, see if I can find a couple of triangles here that I can use. Yeah, I hate to use 2 green ones, but oh well. If I have these 2 triangles, we could have something like this. What do I know about this center side and these 2 triangles?
They're equal.
It's the same thing, isn't it? So anything equals itself.
Yes, sir.
Now, where it becomes, it always takes me a second to figure out how to do this. It gets a little harder when you have something like this. Does everybody see the 2 different triangles?
Yeah.
What do we know about this segment in both of them?
They're equal.
It's the exact same segment in both of them if we took them apart, right? So anything equals itself.
Whoa.
Then the other thing that we could have,
Man, that's confusing.
I can't never,
What, just like, prove both.
I'm trying to do one special thing, I gotta remember.
Just do it.
I gotta remember
Yeah.
how to lay it.
Maybe.
Here we go. I think I got it. Yeah. Fine. Does everybody see the 2 triangles still?
Yeah.
What do they share now? Do they share this side?
Yeah.
No, because it doesn't go all the way down, does it?
No.
Do they share this side?
No.
No. Do they share this angle?
Yeah.
So in that angle right there, what do we know about this angle and this triangle and this angle and this triangle? They're the same. Anything equals itself because those 2 angles are the exact same angle. Now, is this angle and this angle the same?
No.
No. They don't share that, right? They don't share this whole side and nothing else, but they do share that angle. Anything equals itself. Takes me a second. Symmetric property. Symmetric property. All the symmetric property does switches the sides. So a lot of times, you did this last year in algebra and didn't know you were doing it. You solved a problem in algebra last year and it came out like this: 5 equals x.
And then you wrote x equals 5.
You wrote down x equals 5.
Did that.
Alright, and that's what you were using was the symmetric property. So when you switch it around that way, just switch the sides, you're using symmetric property. Transitive property, we just got to, we talked about transitive property last class. If A equals B and B equals C, then what do we know about A and C?
They're equal.
They have to be equal. That's transitive property. A lot of times in geometry, we'll do something like this. Angle 1 is congruent to angle 2. And angle 2 is congruent to angle 3. Then what conclusion can we draw?
What? 1 and 3 are equal.
1 and 3 have to be congruent. Alright? That's using transitive property. Do this for me. Mark out transitive property and write in
Substitution property.
substitution property.
I knew that.
Anytime you're using transitive property, you're also using substitution property. Now, but for it to be transitive property, it has to go in this certain order. Notice here, B has to be the same as B over here. We talked about this with the law of syllogism. These two have to be the same to be transitive property. So if I did this, if I said A equals B, C equals B, this doesn't fit transitive property anymore. Right? But it does fit substitution property. If you think something is transitive property, you're better off to write down that it's substitution property, because anything, let's do a Venn diagram. Substitution property is this, that big circle. Transitive property is inside of it. So anything that's transitive property is substitution, but not everything that's substitution property is transitive. So if you think something is transitive property, you're better off to put that it's substitution, because there's a larger chance or a bigger chance that you're going to be correct. Does that make sense? So I would never ever use transitive property. I would use substitution property, because if it is transitive property, then it's going to be substitution anyway. Does that make any sense whatsoever?
Yes.
Again, anything equals itself, guaranteed. I think I said that we're going to have another definitions test coming up here pretty soon. Guess what's going to be on there? Guaranteed reflexive properties on there, because we use it a lot. Anything equals itself. That's all you have to write. Reflexive property. Anything equals itself. A proof. Proof is a logical argument in which each statement is supported by a reason. Is this on there somewhere or not?
No.
It's not on there. So that's all a proof is. A logical argument in which each statement is supported by some reason.
Wants to write it down.
That's up to you. If you want to write it down, you can. We're going to do these proofs, and there's several different kinds of proofs. The ones that we're going to do, mostly 2-column proofs, and we'll talk about them here in a second. But all it is you make a statement and you give a reason for that statement. You make another statement, you give a reason for it. You got to give a reason for everything that you do. This is what a 2-column proof looks like. There's stuff you got to fill in on that.
Yeah.
I think there is a little bit.
It's just that
A little bit out to the side and stuff.
What's a postulate?
What is a postulate?
A rule that we just like take as true, I think.
Rule, postulate's a rule that we take for granted is true. What's a theorem?
One that we know.
Prove
one that has to be proven true. Then we got properties like we were just covering, all those properties that we just covered. And then you got axioms, corollaries are the same as postulates, then definitions.
Have you ever played that Break the Ice game?
These are the only things, notice I'm ignoring you because you're gonna either focus or I'm gonna set you out in the hallway. The only things that can be a reason in your 2-column proof is one of these things. It's gotta be something. It's not just you saying, because angle 2 is 50 degrees. No. If we were trying to say something about angle 2 being an acute angle, then we'd say the definition. We'd say, an acute angle has measure between 0 and 90 degrees. It has to be a definition, a postulate, a theorem, a property, one of those things. How come these are called 2-column proofs?
Because there's 2 columns.
2 columns. Your first column, always gonna be statements. You make a statement, you give a reason. That's your second column. The first ones, you might wanna write this in some of these. The first one right here, 99.9% of the time, is gonna be given. There's some information that you're given, that's what it's gonna be right there at the beginning. The last statement down here is what you were trying to prove. So whatever that proof statement says, that's what's gonna go right there. When you get to what you were trying to prove, you stop. You don't go any farther than that.
Drink them more than 4.
Yeah, they'll be longer than 4.
It will be.
Yeah, some of them can be. And it could be 2, could be 50, and it could go anywhere.
Stand up at
Most of the ones that we do will probably be 4 to 12, the most. Alright. Most of this, again, as we go through and do this, I'm not gonna make this harder on you than it is. And you'll see, as we go through this chapter, and we do our statements, we do our reasons. What's the first reason gonna be every single time? Given. It's gonna be given to you. Should anybody miss that?
No.
No. There's certain points you should get every single time you're doing one of these problems. If you just skip it, are you gonna get those points? No. You should be able to get that point regardless. There's gonna be other things through here that is gonna be easy that you should get every single time. Then let's say we get down here to our final statement. That's gonna be whatever it says right there in the proof statement. What we're trying to prove. That's what's gonna go right there. So regardless, on a test, if I had this problem right here on a test, this would be worth 10 points. How many points should you for sure get on that test without doing anything? You should get this, you should get that. Now you should also get this, because it's gonna tell you right here what to write there. So actually out of the 10, right now, we should get at least 3 points. If you do nothing, what percentage is 0 out of 10? 0. If we do the 3, what percentage is that? 30%. So you can get 30% even by not trying. Just writing. This is on that other worksheet, isn't it? This is the ones that's on there.
Yep.
I'm gonna show you how to do the first one. So we're gonna do the first one, then I'm gonna sit down and you guys are gonna do them. Let's see, what could I do? Maybe give you some bonus points if you do one on the board. Wanna do that? None of you need any bonus points, do you?
I'm gonna end up reading one.
Nobody needs any bonus points?
I need bonus points.
Alright. This is the way we do these, so watch. So put the blocks away, Branson, so you can see how to do them, so that when you get up here, put them away. Wait a second. Put them back in the little baggie. This is what you're going to do each time. Draw your two columns. What's our first column?
Statements.
So write that in there. I already did it for you, didn't I? I shouldn't have done that. So I already wrote it for you over here. What's your second column?
Reasons.
If it helps you on these algebra ones, the book doesn't even do these algebra ones. I put them in here because I know how much everybody loves two-column proofs. And I put them in here because these are easy ones. Alright, and this sort of walks you into before we jump into the geometry stuff. Okay? So everybody should be able to do these fairly easy. If it helps you with this, go out to the side somewhere, write the problem down, and solve it. How would I solve this? Minus 1.
X equals 2.
What's that leave me with?
3x.
3x equals 6. Divide by 3, x equals 2. Now, in a two-column proof, two-column proofs, write this somewhere on your paper there. A two-column proof is also called a formal proof. It's called a formal proof. What's formal mean?
Fancy.
Professional.
All right, professional, fancy, whatever. We don't want to show our work in a formal proof. Okay? We just want to go down through and do the steps. So we're not actually showing the work because this looks sloppy.
What would a formal way look?
All right? So the first thing we're going to do, number 1. What do you think we write over here as our first statement?
Again.
The given. What's it say?
3x plus 1 equals 7.
3x plus 1 equals 7. That's your first statement. 3x plus 1 equals 7.
So we have to give the give for the reasons also.
Now, we got to give a reason, don't we? How did we know that 3x plus 1 equaled 7?
Because X equals.
It was given to us. And that's what we write over there. Given.
Right, given every time I put one of these.
Make sure. Another thing I need to say. See these? Got to number your steps. You have to number your steps. So each statement's going to have a number. Each reason's going to have a number. The reason we number them is so that I know what matches up to what. Okay? They got to be numbered. Does everybody understand that? AJ, you understand? They got to be numbered. Elizabeth, you understand? They got to be numbered. Now, when you're doing them for algebra, you don't want to show your work in the algebra two-column proof. So we're just saying, all right, we went from this statement
The 3x equals 6.
to 3x equals 6. So that's going to be our next statement. 3x equals 6.
And that's the.
What did we do to go from this to this?
Subtracted 1.
Subtracted 1 on both sides.
Yeah.
And what we write over here, we don't write subtracted 1 from both sides. We want a property, a theorem, a postulate, something like that.
Subtracted property.
Subtraction, and again, you can abbreviate it, subtract, property, and you've got to remember, these are the ones I was talking about. It's got to be subtract, property of equality, because we did it to both sides. Are we finished?
Oh, you already gave the statement reason.
Now what?
X equals 2.
The next thing that we said after that was this right here, right?
The proof.
That's what we were trying to prove.
Do you need 4? Or do you just need as many as, like, how many steps it takes?
I don't know, we'll see.
Okay.
How did we go from number 2 to number 3?
Division property.
Division property of equality.
Division prop of equality. Division prop of equality. What's our next statement gonna be? That's it, we're done. We got to what we were trying to prove, so do we need another one? No, that's it.
Can I go? Yeah.
Oh, you wanna do the next
I
one?
wanna do it. Do I get bonus points?
Do Branson.
I do. Just gotta make sure before I do it.
Pop off.
Randomly, my head hurts now. I think it's that.
Statement reason.
No, I gotta do this in my head real quick.
They're not gonna leave you up there all by yourself, Brent.
Alright.
They'll probably help you. I guess they'll help you. I don't know. Maybe
Please
not.
help me.
I'm not helping you.
Depends
I'll
if
barely
they
pass
like
out
you or
your
not.
Thank you, bub.
Yeah, I'm not helping you.
Yeah.
It's because I do like to.
Yeah, I know. Okay.
Good start.
You need to put given, and that's given. And then. Oh.
That's all right. Just fit it in there. That'll be all right.
Yeah, you know it's there.
So when you put your 2 down,
Yeah.
scoot it out closer to my line that I drew there, so you have plenty of room.
Oh, okay.
Your
Yeah.
answer might not be the same every time.
No, this should be the same.
What if you do something else before you do it?
Like,
Oh, you mean it might not be in the same order?
Kind of.
Yeah.
Like someone could have 5 steps.
Right.
If I was working this out and I didn't have to do this, I would
No.
subtract.
Now, what's wrong with that? To say you didn't have to do that is wrong, because you need to do it regardless, whether you think you need to do it or not. If it's a step in the problem, it needs to be in there.
I'm saying you could do.
Yeah,
Oh,
be
You
in.
could
I read
subtract
it
12
Yeah.
instead of subtracting 4x.
Oh, yeah,
Subtract 4x instead of subtracting 12.
Yeah, but I thought
You
the
could do
first
it
time was
different.
different
Yeah,
size.
that's what I
I
meant.
got you back.
But-
Thank you.
Huh?
I thought, yeah, so do I.
But if you're wrong, I will totally make fun of you.
What did we say? All right, go ahead.
So, do I? Okay, yeah. So, yeah.
Forgot something in there. I know you did. You're right, my fault.
Yeah.
This thing's bleeding.
So, what property is that?
What property did you do?
Would that be subtraction, but I used an X, would that change the
No,
property?
because as long as you did, what did you do to both sides of the equal sign?
I subtracted.
Subtracted.
My handwriting's really bad.
What's gonna happen when he does that?
What?
This goes back to,
No, you have to put subtract. That's
gotta
sub.
go out farther than that, because if he just puts sub, now, is Ebersole gonna be able to read any of that?
You still get your
No.
53 points.
So pull out the eraser, push the indented button. This is when,
The top one.
this is when me and Branson were talking about somebody wasn't focusing. And we couldn't figure out who it was. Push the indented button.
Branson is
No,
not-
no, you see where the 2 buttons are together?
Yeah.
It goes in.
The one that goes in. Now go down to pointer options. Go over to eraser. Erase that. And go back and do the same thing, go to pointer options, go to pen.
I'm like so lost.
Now, what's he gonna write here? Help him out.
S subtract. S-U-B.
Why does he have to write that out?
Because it could have been substituted.
That way Ebersole knows. And what if he,
No, just put equal sign.
that's all right, just go ahead since you got it. Make sure you put equality on there, otherwise it'll be wrong. Are we finished?
No, I need a calculator.
What do you need?
There you go. 4.
4, negative 4.
Okay. Thank you.
It's negative.
Makes sense?
Or negative X.
Sure. X
Straight
equals
And then.
4, right? That's what I was told.
No, they told you something different.
What?
I'm glad it's not only me you don't listen to.
X equals -4.
Oh, -4. My fault. I think this is. Did they?
Yeah,
You need to apologize to my
What?
Yeah, you heard me.
I don't know.
Does everybody agree with that?
Yes. Yeah. Oh my god, it took so long.
Hey.
Should they take that long?
No.
Let's hope not.
I was having pen trouble. So
His jokes have been pretty good today. He
What'd
said,
you say,
I
John?
found him like
I
this.
said,
Maybe
Another
it's-
volunteer.
My dad. Private view with you.
Don't hate me because I'm beautiful. Oh, sorry.
Another volunteer. Instead of messing around, Brent, you should be writing.
Are you sure?
No. Oh, never mind. I thought you were talking.
Someone else.
You have to write.
Nobody going?
Well, Michael's going. Oh no, we're picking up something.
Fair enough.
Let's
No,
go,
he's
Michael!
Shut up.
Thank you.
Bonus points.
I'll win. This thing rolls real good on this board.
Now again, as big as Michael's writing, is he gonna be able to fit it in there? Absolutely not. And, go ahead, just keep erasing. And, when you're doing it on your paper, make sure you can read it, because I'm not gonna strain myself to decide what you were writing. I don't know that I'm gonna worry about Katie's paper a whole lot, some of the other young ladies in here, but some of the young men, you might wanna make sure you write so that I can read it.
Dude, what are you talking about? He can read my writing.
Otherwise, you're gonna be mad at me when you say, well, that's what I had down, and I'm gonna say, I couldn't read it.
Alright.
What's that too? Sorry, just mark it out, well, alright.
Keep them with right out the full words. Okay, now what is this thing?
Man, you look lost up there, honestly.
I'm not.
You look so confused up there.
You have to give it a minute. It's been messing up today.
Paper.
You got done with the ones on the front, flip to the back.
Don't say it.
Wonderful.
I know what you're gonna say.
You were listening. You were listening.
Is your face up?
That's
You
what-
laugh.
Can you do two distributed properties on the
You need to get your
And then
tackle
two
down.
choices, so we can.
There you go, Michael.
separate
Let's
sheet of
back up.
paper.
What are you dressed as? I understand you're a witch, but like, what witch?
Oh
We have
my,
to work out the
the
situation.
Wizard of Oz.
That's what I thought.
You're right.
I would tell you, if you focus the rest of this,
We can
do 11 minutes.
Look at his shoes, we can witch at the waist.
And now just.
He said, earlier he said, I bought him like this, and I laughed so hard.
No, cause it,
That.
you have to go back.
Move it.
It switched screens on.
Minus, yep. Ooh, what is the expert? Right, and it's been a while since we've been doing this, isn't it? So remember And then we move on. Perfect. What happened to these?
You didn't see that I had the two columns drawn for your.
I got so far that I wrote pizza.
Minus.
So what I started doing was.
Good. Now I need to go back to your, what are you gonna do?
Just there.
Hey, I should mind. I got 3.
Look.
What is it?
3.
3?
3? This is 3?
6x equals negative 20.
Negative 8 what?
What?
Equals negative 20.
Equals 32. No, we've done one step, right?
Subtraction from.
I know, this is where people are gonna stop. We've done one step. So that can be your next statement. So, each time says.
No. Does that mean I have to do all of these?
Negative 8x equals 32. And then how did we, what was that, what's the reason? Remember he said it has to be like a
Kinda really
real
happy.
property or something we discussed.
I understand how you do it.
Subtract.
Madness.
Right, but what do we do in
That's
this
interesting.
step? Yeah, we subtract it from both sides, so that's subtraction.
You know my.
So just subtraction, you don't wanna get to the subtraction.
You had to return them.
No.
He works it down.
I feel like I did this wrong.
Mama's thing.
I can't see it.
I got negative 0.25.
Yeah, you divide it back.
That's what it was.
And it's.
Did I do that when it's negative?
It's negative 4.
He could have got 3 months in June, and he doesn't have it. The only reason that it was considered accurate is because you lived with 3 people. If it was just him, it wouldn't be like that.
Awesome.
But what they could have.
Alright, so now we're like one step away, right? And now we can go
What do you
to
need?
our last step.
Because like, you
Get
know,
X
court
along
people
these
and stuff, they can make it
divide
seem
by.
like he was paying that.
Oh, you did,
To
yeah.
where he
Yeah,
had,
you
we
did.
did.
What happens to
Exactly, but that's the only thing that court.
Does everybody agree with what Michael's got up there?
Oh yeah.
Good, so you were.
That should be Cheney for all of
You
us.
think so?
Alright.
On
your feet.
Get
everyone free
I can't believe you didn't Bill Russell.
Why is it not there in that? Why is it not there in that?
Me personally.
Well, that, your opinion doesn't matter.
You
Just
divide
see
it
what
by
her
two,
plot.
right?
Yes, sir.
So not 8x.
These things sit long.
Good. And then how do we get there? What do we call both sides of the equal sign?
They're easy. They
You're
just.
just-
So
Ask him, how does
division.
he stay awake?
I don't know about that.
Sleeps
I'm
early.
stupid.
No, not that.
However you want to.
I went to school early.
Exactly. Because you can't name one.
I'm not alone.
That's a nice one to work through stuff.
Homework.
Pointer options. Yeah, you were on the right one. Pointer options.
Okay. Do me a favor.
Ken.
Somebody.
Eraser.
Yeah, that's her.
Me
Eraser.
or Mrs. Big.
Where Nathan's
Luke or
bigger.
somebody who doesn't know yet. You're the one that's ahead of everyone.
Got
You
it.
have you could put a piece of note paper with this to show your work on.
I'm gonna find a place
What do you use?
for coffee.
It's hard to read.
I will be glad to come with you.
If I miss it, Bill Russell, yeah, but anyway,
Somebody,
it's
do you
fine.
promise? Cause those are your notes and you're gonna want to use those.
You don't give me very
You
much.
said you have nothing to do with it.
Dude, my hand has like 4 blisters.
It is free.
Nah.
Actually, get somebody during intervention, maybe after that.
Yeah, did you play varsity sports?
I remember.
I didn't know that.
No, you can do all those prompts.
Yeah, my story.
So maybe.
I'm not talking about that stuff now. Why? Because we're doing math. Focus.
And then answer.
Focus.
That shit was. You never heard of the same seat. I'm studying.
Maybe no one happened.
You got this. You got 5 minutes.
I love soccer.
And like the dragon.
Okay.
Around
Yeah, you don't mind, I will come over.
Yeah.
Dude, our
Swamp.
swamp like
I opened the chest. And I tell them to like this one.
Dragon burn. Take it to the ceiling and thunder.
Yeah, we're like taking a shoot out. No one.
I need Nick Chubb did not go off.
I died of one.
If he scores more than 18, I lose my game. It's pretty hard to dodge.
I wanted to help the rest so bad. It was hard.
Oh my god, I look like it tonight.
And then
I'm gonna go home. If he scores 18, I lose this score tonight. I have Alvin Kamara,
he's in like this.
ETN, Eckler.
Before you go away, somebody help her out.
ETN reminds me of
Two things not that we can't have up here.
yeah, ETN just like
Sub, trash,
I got him out of the shift and I get Eckler and Alvin Kamara running backs. And two QBs.
Subtraction, wasn't it?
They speed.
Wasn't it subtraction?
And twins like
That is
they have a low.
How was that substitute?
Number two is substitution, right?
Does everybody understand? Did I just say during all of the stuff that we've been doing,
Oh, no.
that if you abbreviate those, SUB, I'm going to mark them wrong?
Yeah.
You got to make sure, and we've had two people, at least two people, as they were doing it on the board, abbreviate them that way. Got, I know nobody thinks that Ebersole knows what he's talking about, but did I say that people are going to do that?
Some creatures just automatically take